All right, today we're pulling back the curtain on how websites are actually hacked. Not the Hollywood version, but the real deal. We're going to break down the playbook, the step-by-step process that both the bad guys and, more importantly, the ethical hackers who stop them use every single day.
So when you think of hacking, you probably picture someone in a hoodie, right? In a dark room, furiously typing green code onto a black screen. But is it really just digital magic? Some kind of frantic keyboard wizardry? The answer is a hard no. Real-world hacking is way less about magic and so much more about a deliberate, methodical process. You know, the professional term for this is penetration testing, or you might have heard it called ethical hacking. And it's not chaos at all. It's a super structured discipline. Companies actually hire these folks to simulate an attack on their own systems to find the weak spots before a real criminal does. To really get it, we're going to walk through the whole anatomy of an attack, piece by piece. First, we'll look at the overall methodology. Then, we'll dive into the 3 key phases: finding the initial cracks, getting a foothold inside, and then, the big one, taking over. And finally, we'll flip the whole thing around and look at it from the defender's point of view. Okay, first things first, let's talk about the core methodology. At its heart, hacking is really a process of discovery. It's almost scientific. You form a hypothesis about a potential weakness, you test it, and then you analyze the results. It's a cycle. And the key word here, really, is identify. An ethical hacker's main job isn't to go in and break everything. It's to find and flag the vulnerabilities. You can think of them like digital detectives, just meticulously searching for clues and weaknesses in a system's defenses.
And that brings us to phase 1. Finding the cracks. I like to think of this as casing the joint, like in a heist movie. Before you can even think about breaking in, you gotta know the layout of the building, right? What doors are there? Are there any hidden passages or unlocked windows?
This initial recon is all about gathering info. First, they do content discovery, which means they try to map out every single page on the site, even the stuff that's not supposed to be public, like admin panels or old backup files. Then comes something called fuzzing. This is where they use automated tools to basically knock on thousands of digital doors to see what opens. And finally, they'll actually read the website's public source code, looking for little clues left behind by developers, like comments or bits of code that hint at hidden features.
And this is what that fuzzing can actually look like. This is a real command for a real tool. Now, don't worry about the syntax here. That's not the point. The takeaway is that this one little line of code can launch thousands of automated requests. It's systematically trying every single word from a massive list to see if a hidden page like, say, target/admin or target/backup actually exists. It's automated discovery on a huge scale.
And if they find something, a hidden page, a forgotten directory, that's what lets an attacker move into phase 2, gaining a foothold. All that information they gathered is now used to find one single way in. It's like finding that one unlocked window in a building that's otherwise totally secure.
Now, to find that unlocked window, hackers have a whole toolkit of specialized attacks, and this is just a tiny sample. Each one of these acronyms represents a different kind of weakness they can exploit. This stuff isn't guesswork. It's a field that requires some really deep and specific knowledge.
Let's just take one of those, cross-site scripting, or XSS. In what's called a reflected XSS attack, a hacker could craft a special link. When someone clicks it, a malicious script gets reflected off the web server and runs in their browser. But stored XSS, well, that's even scarier. The attacker injects the script directly onto the website itself, maybe in a comment section. And now every single person who visits that page automatically runs the attacker's code.
Okay, so once an attacker is inside, they have a foothold, but they're not done yet. And that brings us to phase 3, taking over. This is all about what we call privilege escalation. It's about turning that initial, maybe low-level access into full control. It's about getting the master keys to the entire kingdom.
So how do they do it? Well, one really clever technique is called password reset poisoning. First, an attacker intercepts the request a user makes when they try to reset their password. Next, they inject a tiny, malicious change into that request. They modify the host header so it points to a server they control.
The website server, thinking it's helping the real user, then sends the password reset link directly to the attacker's server. And just like that, it's game over. The attacker has the link and can take over the account. Another really common way they do this involves something called a JSON Web Token, or JWT. Just think of it like a digital ID card. It has a header, a payload, and a signature to prove it's legit. The payload is where the trouble often starts. It can contain info like your username and your role. For example, it might say role user. A skilled attacker can find ways to tamper with this, changing the role to role administrator, and then trick the server into giving them full admin rights.
So far, we've been thinking like an attacker. But now, let's switch gears and put on our defender hat. Because the whole reason ethical hackers go through all these steps is to help companies build a stronger fortress. You see, to defend the castle, you have to know all the ways it can be attacked.
And this really gets to the core challenge of cybersecurity. It's often called the defender's dilemma. An attacker only needs to find one single flaw to get in. Just one. But a defender has to protect against all of them. It is a fundamentally unbalanced fight.
So what do? Well, the defense is basically the mirror image of the attack. To stop things like XSS, you have to validate and sanitize any data that comes from a user. To stop them from taking over, you need strong access controls and secure authentication tokens, like those JWTs we talked about, but configured correctly. For every attack vector we've discussed, there is a corresponding defensive principle. And ultimately, this isn't a battle that's ever really won. It's a continuous race on a track that never ends. As soon as the defenders build higher walls, the attackers just invent new kinds of ladders. Understanding the methodical, strategic nature of this race, that's the first step to being a better defender. Which leaves us with a final question to think about. What part of a website's security do you think is most often overlooked? Thanks for watching.